Shh, guys, that's enough. All right, here we go. All right, so what we're going to talk about today are two different types of compounds. You're going to have to take my word for it. Some people may be aware of what I'm talking about, but I'm kind of going to give you a crash course here. The two different types of compounds that we deal with in chemistry, actually there's three, but I'm not going to talk about metals. I need my eraser here. One of them is what we call covalent compounds. You guys are getting a taste of what chemistry deals with on a daily basis. Okay, the other one is called ionic, I-O-N-I-C, compounds. Okay, now covalent compound, when you have these atoms that come together, they stay put. Things like H2O. What is H2O? Water. And it looks something like this. Water, those two hydrogens will stay with that oxygen irregardless. I mean, if you take the energy to break them apart, that's one thing. But aside from that, water's going to remain water. You can freeze it. You can heat it up. You can turn it into steam. This is going to stay put. They actually share a pair of electrons between the two. Now, that's the key, is they share electrons. Now, with an ionic bond, take a look up here. You have something, this would be potassium chloride. Okay, you may not be familiar with that. Let me give you one that you might be familiar with. Is anybody familiar with sodium chloride? What is sodium chloride? Yes. Salt. It's salt. Okay. Now, what happens in this particular situation is sodium, whenever you look at the electrons, the electron levels that it has an extra electron sitting around the outside. Now, sodium goes, I'm stable with it, I'm cool with it, that's fine. But if somebody would like to take that electron from me, I become just a little bit more electrically stable. Now, an electron, is an electron a positive or a negative charge? Anybody know? Negative charge. Your protons in the inside are positive. So as long as you have the same positive, same negative, they equal each other out. It'd be like if I had, think of it as like a number line, okay? You have a number line. And if I say, well, I'm going to give you 3 positives. 1, 2, 3, right? It's going to land you 3 on the number line, right? Now, if I tell you I want you to add 3 negative ones, that's going to take us in the other direction, right? One of them takes it 1, 2, 3. The other one I say I want you to add 3 minus 1s. Okay, have you guys ever done anything like this? What is 3 times negative 1? Negative 3. So if you add a negative 3, what really are you doing? You're taking a minus 3, right? So it's going to take you the other direction. So if you have 3 pluses and 3 minuses, basically you have a neutral atom, and everything works out fine in the universe. However, if you take an electron from an atom, it becomes positive. And if you give it to another atom, it becomes negative. Now what happens to that sodium and the chlorine, what happens down here with potassium, all these here have a single electron that they're willing to go to. You'll learn about that in group 1. It has 1 covalent electron. So here we have sodium has 1, so does potassium. They're going to connect in the same way. If you get enough chlorines and enough potassiums together that they swap electrons, they will snap together kind of like magnets. Okay? Where you don't have like sodium chloride anymore, you have a whole sea of sodiums with a whole sea of chlorides, and they just kind of hold together. We call it sodium chloride because that's what the whole bunches are, but you can't like take a single sodium and a single chloride and say, oh, this is, and actually they don't even call it a molecule. They call it a formula set or something like that. You've got to have so many, and then as it repeats, you go, okay, that's fine. Now, what's interesting is potassium, by the way, these are all metals. When you have a metal that combines with a non-metal, that's when you're going to have your ionic compounds. So keep that in mind. So with the first one here, I've got to dry these out. What did I do with my there? Grab some paper towels. All right. But all you have are covalent compounds. Right now, you're going to have to live with that. If all you have are covalent compounds, you will not be able to have an electrical charge that will pass through a specific material. Now, so we put up here, water, covalent or ionic? Do they swap electrons or do they stick together? Riker? They stick together. So you have a covalent compound that happens there. Will you be able to conduct electricity through that material? Only ionic compounds allow you to, or that act like ionic compounds. Now here, I have a very special product called distilled waters. Can somebody tell me what distilled water is? Yes. All the minerals are taken out. All you've got is H2O. 100% H2O. Nothing else in it. Where's my top at? All I've got is just water. Now, oops, I almost forgot I got. Is that off? I'm not sure I'm going to shock myself. First hour, I shocked myself. And then what happened is I put this in the banana. And I used, this is not but this is where all the smelly, the burnt sugar smell came from. It was from the banana. You watching on the video, I stuck the electrodes into a banana and it started to burn. No, I don't have a video of it. But the problem is it wasn't just in there for like a minute or two. It was like in there for like 15 minutes. I smelled something to burn. I was like, oh! But it's left it in the banana. All right. Now these aren't perfectly clean. But let's go ahead and do this first experiment. The first observation I would like for you to make. Let me turn all this on.
Everything is on.
Let's see, what's this? Okay, good. Now, what I've got to do is I've got this electricity going to here, and I've got it short-circuited through here. So if I bring these two together, this completes the circuit, okay? If we have electricity flowing between these two, we'll have a complete circuit. Now, if you notice, what is this? Metal, right? It's a piece of aluminum. And what's actually happening between the two here is we have all those electrons are traveling across the surface of that metal and going from one lead to the other and then to the light. So that allows us to know that this is something that will conduct electricity. Now, we talked about the water. All we have is 100% water. Will we be able to conduct any electricity between the two? No. So when we go into here, we don't have any. Now, this, that is sugar. Here we have some salt, sodium chloride. Just think of it, instead of having the sodiums in here, we could, instead of the potassiums, we have sodium. Now, if I begin to put some salt into here, what is that water going to do to the salt? What did it do to the potassium chloride here? What is it doing as the water hits up against it? Well, it's actually breaking them off. This potassium is being broken off here, this chlorine. Again, potassium chloride and sodium chloride are going to behave much the same way. Matter of fact, if you were to taste them each in your mouth, they would both taste kind of salty. Although I think potassium chloride probably isn't the best thing for your stomach. But they do use it in like salt melt. Anybody ever have any ice melt before? Where you might have like the white stuff and then there's like little blue balls in there and there's like different, I'm serious, they actually have little beads in there that are blue and other colors because they mix in sodium chloride, potassium chloride, and magnesium chloride to give it greater ability to get the ice to melt. So this breaks it apart. So let's see what happens. If I put some salt in here, the water will begin to break apart the salt crystals. I'm going to shake this up just a little bit. Keep your eye on the light. Look what happens.
Yo.
As it breaks more and more of the sodium and chloride apart, these actually can begin to carry electrons in between them. And that's what's happening between the two leads here. Now, did it immediately just go turn on? Or what happened? It was kind of a little bit of a process. If I did it over again, matter of fact, you know what I could do? What do you think would happen if I added water to it? What do you think might happen to the light?
Wow.
It would actually start to go a little bit more dim. Watch. Now somebody said, is that because you have less ions? No, actually I have the same amount of ions in here, don't I? It's just they become less concentrated. And it's a little bit more difficult for the electrons to find its way from one place to another. So the more I would have of that. It's almost like if I had a whole bunch of salt, and matter of fact, if I made like a paste of the salt and water, I would stick it through there, boy, that electricity would flow really, really easily. But then if I took that and I threw it into an Olympic-sized swimming pool, is it going to be able to conduct electricity as well? If I had the two leads? No, because it's going to get diluted. All right. So, go ahead and write down on your paper, water plus sodium chloride, or NaCl, is a strong electrolyte. Actually, you can see it starting to grow in strength here just a little bit. I'm going to take that out. I'm going to put that into this bottle because I'm going to need space. So let's see why here in a little bit. So we know that salt plus water creates a good electrolyte. Let's see here. What was I going to do next? Oh, we're going to try some sugar.
Right, there is a question.
Yes.
You take the plug-in and press it up against the water bottle, would you like just put this stuff in and would it light up, like even slightly? You still
No,
have
because
a-
actually the plastic would insulate. The plastic is they would call an insulator. Even if I tried to push up against it as far as I could, I mean, unless I pierce it, there's not going to be any transfer because you can't put electricity through plastic. And that's the reason why they use plastic to surround wires and those sort of things, so that way if you touch them, you don't get electrocuted, which is a good thing. Now, let's see if I can clean off these leads without electrocuting myself like I did first hour. Okay, this is a good thing. Good, man, it's cleaning off too. You can just do it without getting shocked. Don't try this at home, by the way. Oh, and I also have iron here. You can see that iron is a good conductor of electricity. Aluminum is a good conductor of electricity, and salt water is also. But take a look here. Let's try one thing. What if I just shove this plug inside the salt? Do you think that might conduct electricity? What do you think?
That would do nothing.
What do you think? Now, let's try sugar. Let's try sugar next.
It's shallower.
Anybody have an idea as to whether or not sugar will conduct electricity?
It'll work, but it won't be very bright. It'll just be dim.
All right, let's give it a shot. In fact, okay. Get some water here. This is not scientific in the sense that it's not quantitative. We're not taking certain amounts of sugar and certain amounts of salt. What we'll do is first put this inside of here. Salt. Okay. Put that inside the water. We don't have any conductivity, which shouldn't surprise us. So let's try putting some sugar in here. Oh, do you remember what I said? What kind of material is this over here? Metal, right? Metal and a non-metal make
Light.
an ion. Will make an ionic compound. Now, this is sugar. Carbon, metal. Is carbon a metal? Black stuff? No, doesn't conduct electricity. Hydrogen. Although it's over there and at the very top, it's actually in a category all by itself. Is hydrogen a metal? No. How about oxygen? Is oxygen a metal?
No.
Do we have an ionic compound here? We don't have an ionic compound. So let's see what happens. Let's see what happens with a non-ionic compound. Now, water is ionic or not ionic? Not ionic. And we have sugar that's not ionic. Let's see what happens if we have two non-ionic compounds. If it will conduct electricity.
You should throw some salt in with the sugar. If you put salt in with the sugar.
What if you put some salt in it? You know, we can do that with experiment. I'll just put a little bit.
Imagine what explains.
I guess.
But the salt, clearly there is enough water in there that hasn't completely surrounded itself with sugar. Now, if it had been saturated, you might have a problem with getting electricity to work through there. All right. Alcohol. That's nice and
About to
cool.
drink that.
What's that?
Thought you were about to drink that. I was like, don't do that.
Ooh. I don't think that's anything in
That's
this.
just the water that you use to
Oh, I
wash
dumped
out
out,
the
right?
salt.
Okay, that's right, I dumped that out. All right, so let's try another solution here. So this is what you can do as an observation. Sugar water does not conduct electricity. Sugar water does not conduct electricity. And what you can put on there is because sugar is not an ionic compound. Sugar is not an ionic compound. Now, what else did I have? We'll mess around with that here a little bit. I decided what I was going to do is to take some baking soda. Baking soda is this. Sodium. Alexa, what is the chemical compound for baking powder?
The chemical compound in baking powder is sodium bicarbonate. Baking powder is composed of sodium bicarbonate and an acid.
Alexa, stop. Sodium bicarbonate, and actually baking soda and baking powder both have the same active ingredient called sodium bicarbonate. Now, what do we know about sodium? What kind of an element is that? Anybody know? It's a metal. It's a metal. Now, sodium, and you'll also find this out in chemistry as well, these are all metals. Matter of fact, all metals all the way across here. But the metals here, you will not find any of them in nature. They are so active. If I had a piece of sodium and I just made from lithium, if I put it out there on the table, we could all sit there and watch it burn. It will just burn in air. It so actively wants to get rid of that extra electron and wants to combine with something else that it will, just from the air, will combine with the water and create hydrogen gas. It doesn't want to be alone. So here, we have sodium bicarbonate. Sodium bicarbonate. Do we have a metal?
Yes.
HCO. Is that are those metals or non-metals? Hydrogen, is that a metal?
No.
Carbon, is that a metal?
No.
Oxygen, is that a metal? Ah, so we have a metal with a non-metal. What might we think is going to happen here?
Nothing.
It's gonna work.
If we have a metal with a non-metal, what happens?
It's gonna go.
Yeah, chances are
Isn't that
it's gonna create a good electrolyte.
Doesn't that already have sugar involved?
No, I dumped that out, didn't I?
No.
I didn't?
think so.
Then let's do this.
And that's to restart.
That's just,
Never
that's just
mind.
water.
I'll just grab another one. Sodium bicarbonate. Along with some
Hot, huh? I'll grab the vinegar.
water. Give that a little swish. And we should not be surprised to see. Matter of fact, I would say sodium bicarbonate, or you can say baking powder, is a very strong electrolyte. Okay, go ahead and write that down in your notes. Baking powder is a strong electrolyte.
So can you do it just by itself?
Just the powder?
Yeah.
Well, actually, in order for it to have electrical compound, you've got to, it's actually got to be, oh, here, I just put a little in here. Just Got this off here. Just kidding.
I was gonna say, yes, we got to see it happen.
But I did that first hour, and then I ended up shocking myself. So now if you put it in here, we're not gonna have, we won't have any, just in the powder form. It needs to have the water in order for it to, it needs to have the water in order for it to conduct the electricity. Again, don't try this at home. Give this to the professionals. I'm gonna throw this into, it's just the salt sugar mess.
Yeah. That jar.
Now, in here, I have alcohol, isopropyl alcohol. Now here is the here's the chemical compound C3H8O is the chemical compound for isopropyl alcohol. Carbon, metal, metal,
No.
metal,
No.
no. So let's put alcohol all by itself.
Shall work.
Isopropyl alcohol, 99%.
Yeah,
And
that'll
it's
work.
been sitting there without a lid this whole time.
What's that?
It's been sitting there without a lid this whole time.
It's okay. You can actually, I could probably let this sit for weeks and weeks, and it wouldn't, the top is so little, you'd have so little escape. So, anyway, here we've got some alcohol.
You just couldn't breathe in alcohol.
What do we think? This is not the alcohol, this kind of alcohol, if you consume, it will kill you.
No,
And you-
that's
you
why I
can,
was like, you're just sitting in there with no lid?
It's okay. If you have a cut, and you need to wipe it off to make it really clean, sometimes, or before you get your blood drawn, have you ever seen them, they'll wipe your arm with something? It's isopropyl alcohol, because it cleans.
I mean, but like.
It's only toxic if you ingest it, not good.
I mean, if you
okay?
ingest
But
enough
it could be
dose-
like many other things that you wouldn't want to ingest. But anyway, so alcohol.
Yummy.
Okay. You guys have smelled it. I'm not going to bring it around. You guys have smelled alcohol before. Do you think that would conduct electricity?
Yes.
No.
Okay. Riker has a yes. We have a no. Who thinks that it will conduct electricity? Raise your hand. Okay, we have two of you. Take a look. Guys, remember? What is this, Riker? What is this? What element is that?
Oh, carbon.
What is that?
I forgot. I'm not good with the radiation elements.
It's an upper left-hand corner.
Helium.
Hydrogen. Hydrogen.
Hydrogen.
Helium is on the other side. It's not real. That's pretty close. And what about O? What is this? What?
1 and 2.
It's pretty close because they're 1 and 2. But so what about this, Riker? What is O? What is O? Oxygen. Do we see any metals here?
No.
I think we may have a difficult time.
So safe.
Here we go, guys. Let's see if it happens. 3, 2, 1.
No.
Yes.
No
You
conductivity.
are wrong with this.
Matter of fact, over here, now, let me ask you another question. Just by the way, salt. Nope, wrong one. Where's the one I was
You should
switching?
probably label it. Yeah.
Here we go. Salt does not dissolve in alcohol. This is alcohol and salt. However, the 1% here actually is, you need to have some water in here. You can't have 100% alcohol because it would all just evaporate into gas. So, do you think if we add salt to alcohol, do you think that might make it electro?
Yes.
No.
It will.
What do you think?
Because sodium is a metal, so.
Right, but has it dissolved in here?
No.
Oh, no, so.
See? I was pretty fast. I remember the first time I realized this. What's very interesting, you see the frog that I have up there that's in the container?
Which one?
Yes.
This one here.
The big boy.
Yeah. The first thing I did is it was really crunchy. It had dried out.
Like a potato chip.
Yeah, like a potato chip. So what I did is I thought what I wanted to do is I want to preserve it. So I put alcohol in it. I fill it up and I thought, okay guys, okay, Mr. Frog, I'm gonna wait for you to inflate. And then I waited and I waited and I reached in there and grabbed it. He was still dry as a cracker because you need water in there. So what I did is the same thing happened with the little guy here. See the little one here?
Yes. He's a
That-
little man.
What's that?
He's a little man.
He's the little man, he's the little frog. Now does he look all dried out
No.
and crunchy?
He's so taller than him.
Does this look all dried out and crunchy?
Hey,
None.
you could.
Before, whenever I first got him, his eyes were sunken in. It was just like. So what I thought, so what I needed to do is I put alcohol in there, but he did not reinflate. So what I did do is I introduced some water, and slowly over about a week's time, he became rehydrated. But it took a while. It's good.
I mean, he could be like those.
Now he looks a little
cheese
bit more
plates.
normal.
He could be like a
This
cheese
one
plate.
here, I have not added water to.
Is he crunchy?
If you back around, hide your leg.
His stomach is skinny.
Okay, that's what I was talking about. If all you do is have alcohol, he kind of stays crunchy. I was kind of surprised by that. So anyway, so the same thing happens with alcohol. It doesn't interact with the salt. And so, did we try this yet?
No.
Do we think how many people thinks it's going to conduct electricity? Raise your hand. Do you think it will conduct electricity? Okay, Riker. Anybody else?
Well, what? I was.
Do you think it will conduct electricity? Alcohol with salt in it. 3, 2, 1.
Nothing.
No, because the salt didn't dissolve in there. So you can write this down as an observation. Salt mixed with alcohol. I should say salt mixed with, I would put 99% alcohol will not conduct electricity. I'm going to put this into here. And I'm going to wash this out a little bit, get the alcohol out of there. So the next thing we're going to try, usually the form of electrolyte that we all take into our bodies when we've been exercising will usually come from something like Gatorade. But wait, hold on. Will this conduct electricity?
No. You should throw some salt in there, but it will.
Do we have salt? Is there salt in here?
Yes.
No.
No.
Probably.
There's sugar.
Sodium, 160 milligrams, but there's also a lot of sugar in here, isn't there?
Yeah.
Sugar and salt, will that still allow electricity?
Yes.
Yes.
Now, it will be dim. It won't be as bright. Because when we added sugar
If
with
we
the
had
salt,
zero sugar,
no.
we had
That
zero
was the
sugar.
water. So never mind.
We had zero sugar.
What do you think?
It'll be dimmer. The sugar will dim it down. But it'll
I'm
still
sorry.
break.
Sorry.
Yes.
Actually, you're right. Let's take a look here, guys. Gatorade. Conduct electricity. 3,
Dim.
2,
Dim.
1.
Dim.
Get the sugar.
Fairly
Bring
dim.
it down.
And actually, well, actually,
Wait,
well, not necessarily because of the
Salt.
sugar. Go ahead.
I'm more salt.
What's that?
I'm more salt.
Yeah, add salt. See
We
if
could
it's
add some,
fine.
but hold on. Let me explain why it's dim. Could you imagine if you drank Gatorade and it was chock full of salt? You wouldn't want to drink it very much, would you?
It's like having
Okay,
salt
it would be good for you. You need the electrolytes in your body. When you perspire, you lose a lot of salt.
Well, actually, homemade Gatorade has a lot of salt. A lot of salt.
You
It's
make
actually
homemade
homemade.
Gatorade?
Yeah, it's really good.
I want to make homemade Gatorade.
But the whole point being is
It's
there's
really like 4 ingredients.
they offset a lot of the sugar, or a lot of the salt, I should say, with sugar. And it will be salty, but it's not going to be like dump a pile of salt in there and drink it. But let's try adding some salt. Let's try adding some salt and see what happens. So go ahead and write that down. Gatorade conducts electricity weekly. W-E-A-K-L-Y, not every week, but weekly. W-E-A-K-L-Y. Because of low concentration. Gatorade conducts electricity weekly, W-E-A-K-L-Y, because of low concentration.
Oh my gosh.
So now we're going to add some
Give it
salt to
a-
it. Let's add some
Low
salt.
concentration.
You know what? Do you know what I'm gonna try? I'm gonna try adding some salt. I'm not gonna mix it. Let's just see. Here we go, guys.
5 minutes.
You getting brighter?
Yeah,
Yeah.
it's a teeny bit.
Teeny bit?
Little bit.
Let's dump some salt and see what happens.
Make it as bright as possible. Like just keep putting salt in.
You see how
Until
bright
it
it
pops.
gets.
Yeah, until like
Until the light bulb pops.
I'm.
Just till it goes.
Please no. That'd be funny.
I would.
What if it just?
Wait, you just got dimmer?
So did you.
Oh, that's kind of nice.
Why don't you throw
So,
some
write this
alcohol
down as the next observation. Gatorade with high salt content. Gatorade with high salt content conducts electricity
Better.
well. Yes.
Throw some alcohol in with it, so now you have some alcohol.
Was that, alcohol would do nothing but diminish it. It would make it less. One other thing, I want to do something.
Or water.
Did the 5-minute bell come off?
Yeah. We have
So
like 4
here.
minutes.
Alright, we're gonna try one more thing.
Oh.
Oh, I forgot to do this.
Do what?
Now here, what did I have in here?
I don't.
Water.
Salt.
Alcohol.
I had
Salt.
sodium bicarbonate.
Salty alcohol.
Oh, you know what, we didn't do that.
Should be
I'm
alcohol.
gonna dump this into here. I'm gonna take a little bit of water. I'm gonna wash this out, guys. This is kind of cool. This was the highlight of the other class, so hopefully I can do
You
this.
know what you should try?
We're gonna try vinegar. We're gonna try vinegar really quick.
Oh, yeah.
Vinegar and baking soda.
Yeah, vinegar, baking soda. I love that.
So, what do you think, guys? Really quick. Vinegar, do you think it will conduct electricity? Yes or no? It is.
Yes.
It is an acid. So yes, you think so? Yes?
Yeah.
What's that?
Yeah,
Put baking
put it
soda
in.
in.
Hold on.
Leave it after.
3, 2, 1. Yes. Now,
Now put baking soda in.
Baking soda.
Baking soda.
vinegar conducts electricity depending upon concentration. This is only 5% vinegar in here, and it does conduct electricity.
You get 100% vinegar and throw some,
Wait, what was it?
Baking soda.
Vinegar conducts electricity.
It conducts electricity well, depending upon its concentration. Keep in mind, guys, a lot of how well it conducts electricity is going to depend upon its concentration. So here we go. Vinegar in with, what is this again?
Baking
Soda. Let's take a look.
Yes.
Beautiful.
But you just gotta put some, you just gotta put straight baking soda and straight up, like, handful.
So you're gonna really make me make a mess, so I'm gonna have to clean it all up. Actually, that's what I did second hour.
Just without water or anything, just put vinegar and baking soda.
Yeah.
That makes it way
I
better.
mean, just in here, like,
Yeah, like in that, and then so throw some vinegar in there.
And put the duvet
Put
back.
those
alright,
Put the plug in.
let's take a look. What's that now?
Put the plug in.
Yeah, and see if it'll work.
Okay, yeah, we can actually add them together.
Yeah.
Yeah.
So what can we say about vinegar plus baking soda? Vinegar plus baking soda is a very good electrolyte. Vinegar plus baking soda makes a very good electrolyte. I would say almost as good as probably just having the aluminum. Make sure your name is at the top of it. I want to collect those before class is over.
I was gonna start that. Too bad. I'm gonna make my own experiment. I got
I literally said, do not try this at home.
Do not try this at home.
I will try that.
Do not try this at home.
I will try it out.
Yeah.
I'll try it at the park.
Go with your parents first. I'm telling you, don't try it at home. You're like, I'm gonna try it
I'll
at
go.
home.
I'll go.
Do I have everybody's paper? Do I have everybody's paper? Everybody's paper, okay. All right, guys, you guys have a good lunch. I'll see you 8 hours. I think. I'll see you guys 8 hours.
Wow.
No, because you guys are headed out.
Really doesn't cost them enough.